Welcome everyone. For today's prep, we're just going to look at another example for calculating the derivative of a function using that limit definition of our derivative. So the key phrase here is we're going to do this using that limit definition. So before we do anything else, let's just write that down. Let's remember what this is. So our limit definition of the derivative, and again, we use this f prime to denote the derivative of the function f. And this is the limit as h goes to 0 of f of x plus h minus f of x all over h. So that's our limit definition. This is what we're going to use to calculate the derivative. All right, so our function in question here is this x cubed minus 4x. So the first thing we want to do is, and probably the trickiest thing, is we got to work with this f of x plus h. So what this says is it's saying take parentheses x plus h, and wherever you see an x in the original equation, replace it with parentheses x plus h. So that's what we're going to do. We're going to plug in parentheses x plus h into the formula here. So each step of the way, we're going to write our limit sign. Let's see what we get. And when we do this, we're going to write our fraction. And let's set up a nice big set of parentheses for what we get when we evaluate this x plus h, when we plug it into our function. So first, I see that I'm going to have an x right here. So instead of an x, it's almost like we're going to kind of wedge in here a little parentheses x plus h. So we're going to get an x plus h cubed. And then we got another x right next to that negative 4. So we're going to have a minus 4. And then, again, it's like we're kind of squeezing in a parentheses x plus h there. So we're going to have parentheses x plus h. All right, so this is what we get for our function evaluated at x plus h. All right, so what else is in our formula here? Well, then we're going to subtract, so we'll have our subtraction sign. And then we're just going to write down the original formula of our function, f of x. So the original formula here is just this x cubed minus 4x. So again, let's get a nice big set of parentheses, and then we'll write out just the original function, x cubed minus 4x. And then all of this is going to be over h. All right. So we have the setup here. Now, when we're doing these power functions, our strategy is just kind of multiply things out, and once we have everything multiplied out, we want to do the subtraction up here. So let's work on getting this x plus h cubed all multiplied out. And let's actually kind of skip, leave a little space here. And let's actually just work on this further down. So for x plus h cubed, and if we're not sure, let's just write it out. So we have 3 copies of x plus h. We're just multiplying them all together. There we go. And to do this, just start with the first 2. Multiply those together. And we did this in class. And when we multiply the x plus h with the x plus h, we're getting x squared plus 2xh plus h squared. And then we still have this x plus h. All right. So we still got to do the multiplication here. And now we just kind of do the distribution just like regular. So I go to whichever term has the smaller number of pieces to it. So I'm going to look at this x plus h, and I'll start with the first term, and I'm just going to distribute it, multiply it into everything in the first piece here. So when I distribute in that x, I get x cubed plus 2x squared h plus h squared, no, x times h squared. When you do this, you want to be just consistent with the order that you write the variables. So I kind of started with x first and then h. So that's why I kind of switched the order here. And then we do the same thing for the second term. So once we multiply everything, then we go on to the next term. And again, we just distribute that to everything in the first piece. So I'll multiply that there, there, and there. And when we do it, we end up with, when we multiply with the first term, we end up with x squared h. When we multiply with the second term, we end up with plus 2x h squared. And then finally, when I multiply it with the last term, I get an h cubed. And if I simplify this down, what are we going to end up with? Well, we want to try to combine like terms. So in order for two terms to be considered similar, they have to have the same number of x's and the same number of h's. So when we look at this, there's only one term with a x cubed in it, and it's this first one. So there's nothing we can combine it with. So it's just going to be x cubed. And same thing, there's only one term with an h cubed. So that's kind of like its own thing. So we're not going to be able to really do anything with those. So we'll put the h cubed at the end. But all the other ones, kind of in the middle there, they do have like a similar counterpart. So let's start with the first one. This has 2 copies of x and then 1 copy of h. So we want to look for another term that has that same thing. 2 copies of x, 1 copy of h. We see it right here. So now we have 3 copies. So this is we can combine those into 3x squared h. And then if we go on to our next term, this has xh squared. So it has 1 copy of x, 2 copies of h. And if we look at the other term, same thing. 1 copy of x, 2 copies of h. We can combine those. So we have 1 of these, 2 of these, 1 of these here, 2 of these here. So if we do the combo, we end up with, again, 3 copies of x times h squared. And there we go. That's as far as we can simplify this. Now, if you've seen it, there's a way to remember the coefficients of these terms. And if you notice, all of the exponents add up to 3. So here we have 2 and a 1. They add up to 3. Here we have a 1 and a 2. They add up to 3. And then we just have a 3. So there is a way to kind of remember how these multiply out. But it's worth the practice to just try and do it by hand as well. All right, so that's honestly probably the trickier part here, is just getting that all multiplied. So now let's take this and let's go back up to our problem. So our limit calculation, we're doing the limit as h goes to 0. Let's fill in what we found for that x plus h cubed. And again, let's keep it all inside a nice big set of parentheses here. So we'll have our x cubed plus 3x squared h plus 3xh squared plus h cubed. And then let's distribute that -4. So we'll have a -4x minus 4h. And then that's it for this first term. And again, it helps to have the parentheses. And then there's really nothing to do in that second term. So let's just write that again. And this is all over h. All right, so we got a lot of things going on. Now we want to try and do the subtraction. So we kind of start by eyeing the kind of the smaller parentheses over here. And usually the way this works is all the stuff over here should eventually get canceled off. And before we do this, why are we multiplying all this out and everything? Well, whenever we're doing a limit where we're approaching a number, first thing we should try is, well, just plug in this case, plug in 0 in for h. If we do that here, we're going to end up with that 0 over 0 form, indeterminate form. So we have to use our algebraic methods. So that's why we're kind of multiplying all this out. All right, so let's look at all this. And we see that we have an x cubed right here. And in the first piece, we have an x cubed. And then right in the middle, we're subtracting. So those x cubes are going to cancel out. We also have a negative 4x in the second piece. And then we also have a, there it is, negative 4x here. And we're subtracting. So those negative 4x's are going to cancel out. And once you get all this stuff canceled here, let's rewrite what we have for our fraction. So we have the limit, h going to 0, and then we have, and actually we can drop the parentheses now. So we have a 3x squared h plus 3x h squared plus h cubed minus 4h all over h. And if we look, all of these terms in the numerator have at least one h in them. So we can factor out an h. And when we do that, we end up with h over 3, or h times 3x squared plus 3xh plus h squared minus 4 all over h. And then we see that we can cancel here. So we factor and cancel. So one of our algebraic strategies for doing these indeterminate form limits is we try and factor and cancel out that term in the denominator that was giving us 0. And so when we do that here, we end up with then the limit of 3x squared plus 3xh plus h squared minus 4. And now, as soon as we do that cancel step, once we rewrite it, the very next thing should be to actually do our direct evaluation. So we're going to plug in h equals 0 wherever we see an h. So I see an h right here, and I see an h right here. So when we do our direct evaluation, we end up with 3x squared plus 3x times 0 plus 0 squared minus 4. And if we simplify that down, 0, 0, so we end up with just our 3x squared minus 4. And so this result, this is the derivative. So our derivative, what we found, is that f prime is 3x squared minus 4. So we started with a function, f of x, we had a nice formula for it, and what we end up with is the derivative. We're calling this just a brand new function. We're calling this f prime, and we have a nice formula for this derivative. So it's 3x squared minus 4. All right, so in class, we're going to get a little more practice doing these. So we'll try some other derivatives, square root functions, rational functions, see how those work. But we've already developed the algebraic techniques for how to actually calculate those limits. All right, so we'll see you in class. Bye-bye.